Hello. Hello everyone, welcome to the online refresher course. I hope and only 10 people are watching and still many more are about to join. We have waited for the 5 minutes. Well, okay. I'll wait for 1 more minute and then we'll start the class. Okay. Till then, I'll just give you a brief about the class. This class is about as I have already mentioned on the slide here, it is a refresher course, okay, which will be conducting or almost like 30 days of classes will be there. In that, 15 hours will be dedicated for aptitude training and verbal training will be for another 15 hours or 15 days, because every day the class will start from 6 o'clock in the evening and it will be there for 1 hour. So the class timing is 6 to 7 p.m. Okay. So I hope all of you understand and will attend the class as well. And then it's me, Shweta Babli, who is a senior trainer in Genesis. So I'll be taking aptitude training for 15 hours of your class. What all contents will be taught, all those things I'll give you in detail. Well guys, now let us move into the next thing. Here, in this 15 hours of online refresher course, I have divided into two sections. One is quantitative aptitude and another is reasoning topics. First, let us start with the quantitative aptitude talks, which all topics I'll be covering in quantitative aptitude. First, we'll start with the number system. This I have divided actually for 2 classes. Today also I'll take number system and tomorrow again a number system. What topics will be covered today, what topics will be covered tomorrow, I'll let you know. Next, we'll start with the percentages and then profit and loss, time and work, time, speed and distance. Next content is permutation and combination, probability, averages, mixtures and allegations, ratio, proportion and variations, data interpretation. So these are the 10 topics that we will be handling in quantitative aptitude topics. And next, in reasoning, I'll be starting with the number series, letter series and coding decoding for 1 hour. And the next class will be on blood relation and direction sense. And next class will be on seating arrangement, and the last class that we are going to handle on this 15 hours of aptitude training is on clocks and calendars. Now, which kind of questions that we are dealing with in this refresher course? These questions are mostly from the model question papers of Infosys, Cognizant, Wipro, TCS and many more. Okay, Google, Amazon and many more mass recruiters usually they're handling. Clear guys? Well, so the questions will be important. Why? Because you'll get to know the pattern of the questions here. Next, in this class, as I said, we'll be starting with the number system. Now, how I have divided this 1 hour, I'll directly give you a class flow. Okay. In the class flow, well, we spoke about the course now, and then I'll start with the divisibility rules, which will be for 20 minutes. In that 20 minutes, I'll teach you some concept and then we'll get into the problems. I'll solve you some problems and then I'll give some 2-3 problems for you to solve. Okay. So that you can get to know here itself whether are you able to solve the questions or do you need any more practice. And then in next subtopic that I'll be handling in number system is unit digits, and we'll be again having the quiz on unit digits for another 5 minutes. And last I'll give you 5 minutes again to ask any queries or any doubts if you have in this particular class, and at the end I'll tell you what will be the class for the next day. Clear guys? Okay. Now before we begin, one more thing I would like to mention. Here you can see the live chat box. Suppose in between the class, if you get any doubts or any problem you are facing, what you can do is you can text or comment in the comment box. I'll look at your comments and I'll reply for all your valid comments. Clear guys? And other than that, if you go to the description, I have given the Telegram link in the description box. So please go there, join the Telegram channel. If you join the Telegram channel, in the Telegram channel, what we have done is we'll be giving you the quiz link on the topic which we are going to handle today. Whatever the topic is completed today, about 7 o'clock I'll end the class. After 7 o'clock, that you can enter the Telegram channel and go there, open the quiz link, and the quiz will be for 10 questions will be given. So please attend the quiz. If any doubts again, you can text in the Telegram box and someone will be there and they'll definitely help you to clarify your doubts. I hope everything is cleared. If you still have any doubts, please make sure that you are commenting in the commenting box. Clear guys? Okay, let us start with the class now. Now, as I said, the first thing that we are going to learn in number systems is divisibility rules. Okay. So that first we'll learn some of the rules and then we'll solve questions based on divisibility. When it comes to divisibility, the first and the foremost rule that we are going to learn is for 2. Now what is the divisibility rule for 2? The divisibility rule for 2 is the last digit should be an even number. Easy, right? Any number you take, for example 2, 4, 8, 6. Now what 6 is an even number and it is a units place or last place, last digit. So if this digit an even number, then this number is divisible by 2. Well guys, so I hope this is easy, and now we'll go for the next rule. Next is the divisibility rule for 4. Here for this, the last 2 digits should be divisible by 4. Okay, if the last 2 digits are divisible by 4, then the whole number is divisible by 4. For example, any number you take, 1, 2, 6, 4, 5, 6, 4. Okay, this is this long. One thing is, what you will do, usually you will start dividing all the number. Don't do it. What you have to do, just check the last 2 digits. Is 64 divisible by 4? Yes, right? So if the 64, the last 2 digits is divisible by 4, then the whole number is divisible by 4. Clear guys? Okay, since it's a refresher class and the divisibility rules are easy and it's easy for all of you to understand, I'm taking just 1 or 2 examples here. Okay, then we'll solve some basic questions based on this. Next is the divisibility rule for 8. Now, why I'm taking 2, 4, 8, all of them together? I hope now you understood. What is that? There is a comparison or the similarity between all of them. So, I'm taking those which are similar together. Now, the divisibility rule for 8 is the last 3 digits should be divisible by 4. Right? Any number you take, for example, 1, 2, 6, 9, 8, 4. If 984 is divisible by 8, then this whole number is divisible by 8. Suppose if 984 is not divisible by 8, then this whole number is not divisible by 8. Is this divisible by 8? Just check. 9, 8 ones are, and then 16 you will get, 2 will be carry, so divisible. So 984 is completely divisible by 8. So this whole number is divisible by 8. Clear guys? Okay. I hope you understand. If you have any doubt, as I said, you can write it in the comment box and send it to us. Okay. There is the live chat option here. Next, we'll go for the next type of divisibility rule. Here, the divisibility rule for 5. Next easiest one. Now all of you, this is the easiest one, right? The last digit should be 5 or 0. Any number you take, simple, 1, 2, 5, 0. 1, 2, 5, 5. So last digit is 5, last digit is 0. If the last digit is 5 or 0, this whole number is divisible by 5. As simple as that. Now next rule is 10. I think all of you know the rule for it. The last digit should be 0. Any number you take, then if the last digit is 0, then this number is divisible by 10. As simple as that. Well guys, now let us go for the next one. Okay. The next divisibility rule is for 3. Okay. Now what is the divisibility rule for 3? Here, if you go for 3, I have written sum of the digits should be divisible by 3. You can take any number you want. For example, 2, 4, 9, 5, 1, 6 is a number. Now you have to check whether this number is divisible by 3 or no. How are you going to check? You have to take sum of all these digits. Now and then divide it by 3. Okay. First take the sum of all these digits. 2 plus 4, 6. 6 plus 9, 15, 20, 21, 27. Is 27 divisible by 3? Yes, it is divisible by 3. So this whole number is divisible by 3. Okay. One more method is, what you can do is, you can cancel out all those numbers, digits together or separately which are divisible by 3. Example, is 6 divisible by 3? Yes, cancel it out. Is 9 divisible by 3? Yes, cancel it out. 2 plus 4 will give you 6. Again 6 is divisible by 3. So you can cancel it out. 5 plus 1 is 6. So 6 divisible by 3. One is this method. One more is you can take the sum and divide it by 3 and try it out. Clear? Easier, right? So yes, the divisibility rules are easier. You can try it in this way. And the next divisibility rule is the divisibility rule for 9. It is again the same as 3. Only difference is here you are dividing it by 3 and here you have to check for divisibility of 9. You have to check it by dividing it by 9. Example. Let me take some similar example. 5, 1, 6, 2. Okay. Is the number. 2. We'll add one more. 3. Is this number divisible by 3? Or no, divisible by 9 or no. How are you going to check it? What do you have to do? You have to add all those numbers and try dividing it by 9. If it is divisible by 9, then the whole number is divisible by 9. If it is not divisible by 9, then the whole number is not divisible by 9. Try. 2 plus 4, 6. 6 plus 5, 11. 11 plus 1, 12. 12 plus 6, 18. 18 plus 2, 20. 20 plus 3, 23. Is 23 divisible by 9? No. So this number is not divisible by 9. Or one more method is, as I said, you can go for all those numbers adding together and check it for 9. 4 plus 5 will give me 9, divisible. 6 plus 3 will give me 9, so divisible by 9. 2 plus 1, 5, 3, 3 plus 2, 5. So 5 is not divisible by 9. That's why this whole number is not divisible by 9 and 5 is the remainder. Clear guys? So now we have learnt the divisibility rule for these numbers. Next what we'll do is we'll learn the divisibility rule for 6 and 7. The divisibility rule for 6 is, what you have to do is check the divisibility for 2 and 3. If the number is divisible by 2 and the number is divisible by 3, then the whole number is divisible by 6. If not, the number is not divisible by 6. Correct? Now, you already know what is the divisibility rule for 2. You already know what is the divisibility rule for 3. You can check for both of them. If both of them is valid, then that number is divisible by 6. Well, we'll take an example for your convenience. Okay. 3, 9, 6, 2. You have to check whether this number is divisible by 3 or 6 or no. How will check? First is 2. What is the rule? Even number. So it is divisible by 2. What about 3? divisible by 3, divisible by 3, divisible by 3, but 2 is not divisible by 3. So this number is not divisible by 6. Clear guys? Okay. And the next one is 7. For 7, either you can go for a usual method, that any number is given, you will start directly dividing it by 7. For example, 7, 9, 8, 2. What you can do? You can directly start dividing it by 7. 7 ones are 7, 1, 7, 1 in that way. Or else, I'll give you one more method. You can go for any method. If you feel usual method is easy for you, you can start dividing it by usual method. If not, what you can do? You can go for the method that I'll give you now and try using it. Okay. Well, let me give you a method for it. For 7, what is the method? Okay. Here, for 7, any number will take, for example, 3, 3, 4, 2. You have to check whether this number is divisible by 7 or no. How are you going to check it? First, remove the last digit and then multiply by that last digit by 2. What is the answer? 2 2s are 4. Now subtract this 4 from the remaining numbers, remaining digits. I'm sorry, not numbers, remaining digits. So 4 minus 334 minus 4 is how much? 330. Now, if you can divide this directly by 7, go for it. If not, again repeat the same procedure. Remove the last digit and then multiply it by 2. What you will get? 0 multiply by anything is 0. And if you subtract 0 from 33, what you will get? You will get the same number. Is 33 divisible by 9? If 33 is divisible by 7, then this whole number is divisible by 7. If not, this number is not divisible by 7. Okay. So 33 is not divisible by 7. That's why this number is not divisible by 7. Clear guys? So you can go for this method or you can go for a usual method. It's up to you now. Well, now we have completed all the divisibility rules. Okay, up to 10. Remaining, if we get any of them in the questions, I will teach you there. For example, 11, 12, 82, 77, something like that. Okay, that if any random number is given, that also you will get to know how to approach it. Well guys, now let us directly jump into the questions. I hope all of you now remember the divisibility rules, and those are easy as I said. So we'll directly start solving the questions. Till now, if any of you have any doubts, please make sure that you type it in the live chat and send it to me. Okay, I'll help you to clarify the doubts. Well guys, okay. 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 So as I'm not getting any of the messages, I assume that none of you have any doubts till here. So we'll directly start with the problems now. Which of these numbers is divisible by 3 is the first question. Okay. Now how to approach this question? What we have done is we have already got to know how to check the divisibility for 3, correct? So using that, we'll go for this. Which of the number is not divisible? So please concentrate here. Okay. Even though this number is the simplest question and this question is asked, it is present in the TCS model question papers. Okay. From where I have taken this question, I have mentioned it in the bracket. Now, how to check? As I said, is 3 divisible by 3? Yes. 3, yes. 9, yes. So, this is divisible by 3. 3, yes. 4 plus 2, 6, yes, it is divisible by 3. Again, 5 plus 5, 10, 10 plus 2, 12 and 12 is divisible by 3. So, all these 3 numbers are divisible by 3. Then, your answer option has to be this. Okay. So, in the exam, you can directly write this and go ahead. If not, you can check 1 plus 1 plus 1 plus 1 4 times. It will give you 4. And is 4 divisible by 3? No. So, This is your answer. Clear guys? This is how you can check for it. Now, the first question we have taken an easy question. Now let us go for a bit different type of question. Again it is easy but a slightly different. Again this question we have taken it from TCS. What is the smallest positive? Okay, read the question properly. You have to go for smallest and a positive which has to be a 2-digit number and a whole number. Okay, and that number should be divisible by 3 and such that the sum of its digits is 9. So there are almost 6 conditions here, and go for them one by one and you will get your answer easily. Smallest. Among the given options, we can try any options. First, since they have mentioned the smallest, we can directly go for a option C, because the option C is the smallest among the given options. Next, positive number. Yes, it is a positive number. 2-digit. Yes, it is a 2-digit number. Whole number. Yes, it is a whole number. Right? What is the condition for whole number? It starts with 0. 0, 1, 2 till infinity. Is it divisible by 3? Check. 1 plus 8 gives you 9 and 9 is divisible by 3. So this number is divisible by 3. Such that sum of its digits is 9. Is sum of its digits giving you 9? 1 plus 8 will give me 9. So all the conditions are satisfied for option C itself. So no need to check for any of the remaining options. Okay, you can directly mark the option C and go ahead. Clear guys? Okay, so the answer is option C. Let me go for the next question. The next question here is, find the remainder when 2989 is divided by 14. Okay, so answer options are 7, 6, 2 and 1. Okay, now I'll give you two methods for this to find the remainder. One is, as usual, 2989, take 2989 and start dividing it by 14 and you will directly get the remainder. Okay. If not, suppose if you are not comfortable with this method, what you can do is, you can go for any other method. I'll tell you one more method for it. 2989, 14. What is the divisibility rule for 14? The divisibility rule for 14 is, the number should be divisible by 7 and the number should be divisible by 2. Okay, and check whether if you want to get the remainder, what you have to do from the given options, you have to subtract something, and if that number is divisible by 7 or 14, then you will get this, that will be giving you the remainder. Okay, now we'll try doing it. 2989, if I subtract from 2989, if I subtract, we'll first go for even numbers. Now you'll get to know why. If I subtract from 29896, I'll get as 2983, an odd number. Is it divisible by 2? No. So this option is eliminated here itself. And next we'll go for second, 2989 minus 2. What you will get? You will get 2987. Is it divisible by 2? No. So you can eliminate this option directly. Left with option A and option D, and any one has to be your answer. You can start from any of the options here. So what we'll do is, we'll start with we'll take option A, 2989. If you subtract 7 from it, what you will get? 2982. Okay, is it divisible by 2? Yes, it is. Now we have to check it for 7. Okay, so one is the usual method, or one more is the method that I taught you just now. Now just to make sure that you learn that method properly, I'll take that method again and teach you. Okay, so last digit 2 2s are 4 and subtract 4 from the remaining digits, you will get 294, and again remove the last digit 4, 4 2s are, you will get 8 and subtract it. What you will get? 21. Is 21 divisible by 7? Yes, it is. So this number 2982 is divisible by 14 and the remainder is 7 for 2989. Okay, so you can go with this method as well. I know this method is a bit lengthier, but why I have taken this method is, one is to explain the divisibility for 14 and one more is to explain this method again. or else you can directly go for divisibility and get the answer. As simple as that. Okay guys? Well, let me go for the next question now. I hope none of you are having any doubts. If you have any doubt, please make sure that you will enter it or type it in the comment box and send. Okay? I'm sorry. Okay. Now, the next question is, what could be the value of x to make a number 3, 4, 5, 6, 7, x divisible by 9? A very simple question on divisibility rule again, right? How to solve this? What could be the value of x? Here, x. Now, what is the divisibility rule for 9? The divisibility rule for 9 is, you have to add all of them and try dividing it by 9. If it is divisible, then the number is divisible. Okay. So, let us do that. 3, 4, 5, 6, 7, x. And this question is taken from Wipro. 3 plus 4, 7, 7 plus 5, 12, 12 plus 6, 18, 18 plus 7, 25. For 25, what you should add? To get this to make this number divisible by 9, you have to add 2, which is the nearest, right? You have to always add a nearest number. So 27, and which is divisible by 9. Okay. So what you are adding as x? You are adding 2, and that is your answer. As simple as that. Okay. Well, now I hope you understood the questions. What we'll do, or how to apply divisibility rules for the questions. See guys, on the divisibility rules, the questions asked will be usually very simple questions, and there will be a bit amount of trick that you need to use. If you understood that, then it is easy for you to solve any type of questions on divisibility rules. Clear guys? Okay. Now what we'll do? Now I'll give you some questions to solve. Okay. So go through those questions and try solving it. Okay. If you are not getting the answer, I'm here to help you. Okay. So the question is, what should come at place of x to make 3, 2, 5, 6, 8, x, 7, 8 exactly divisible by 4? And the options are, option A doesn't matter, option B 4, option C 2, and option D 0. Okay. So I'm giving you 1 minute time for each of the questions here. Okay, Abdul is saying hello. Yes, Abdul, any doubt? If you have any doubt, you can type it in the comment box and I'll try to answer your doubts. I'll try to clear it. Okay. Well, now the time which is given for you, the 1 minute of time is over. Well, what we'll do, I hope most of you got the answer, but none of you have commented. Anybody, if you got the answer, please comment it in the comment box. What's the answer, guys? Please, if you get the answer, please do comment so that I'll understand that you are getting or you are understanding. Okay. Well, let me help you to solve this question. Okay. Now, what is the question? What should come at the place of x? Where is x? Here. To make this whole number which is given here exactly divisible by 4, right? Yeah. Adarsh, Ashrifa are saying yes. Yes, guys. Answer is doesn't matter. Those who are not getting, Aishwarya is saying the answer is 1. Good, Aishwarya. Yes, answer option is A. So let me explain how the option is A. Because as you know, we learned divisibility rule for 4, right? What is the divisibility rule for 4? You just have to check for the last 2 digits, right? If the last 2 digits, 78 here, the last 2 digits, if this 78 is divisible by 4, then this whole number 32658x78 is divisible by 4. If not, this whole number is not divisible by 4, right? So whatever the value of x, which doesn't matter for us. So the answer is option A. Now all others are understood, right? Yes, Nagaprasad, not able to solve. Now, yes, Nagaprasad, now I have explained it. I hope you understood, right? Vinay Kumar A, correct. Well guys, now I hope all of you got the answer for this. What we'll do is we'll go for the next question. Okay. Now apply the same method and try to solve this. You learned the divisibility rule for all these numbers except 12. So try doing it. Okay. It's easy. If you want, I'll give you the hint for 12. For 12, what you can do is you can take a prime factorization. Okay. Yes, okay, Nagaprasad. I hope you understood. Anybody got the answer for this? Second question. If you get the answer, make sure that you comment your answers in the comment box. And I hope I am audible to all of you proper. If the voice is low, you can comment that as well. Okay. Jayadev Prakash is saying the answer is option A. Okay. Hita is saying the answer is option C. Well guys, I am getting different answers. Anyone else? Okay, your time is up now. Now, Chandan Sriramit is saying answer is option C. Okay, two of them got the correct answer. And Jayadev Prakash, answer is not option A. But yeah, still you are near. Okay. Now, let me ask. And I know you went wrong in 12, I think. Okay. So, let me explain the question for all of you. The least perfect square number which is exactly divisible by 3, 4, 7, 10 and 12. Right. So, and some options are given here. What you have to do, you can either go for all the options one by one and check. Okay. Or else we'll try one by one for this 3 and check all the numbers, 4 and then check all the numbers. Any method you can use. Okay. So, let us go with this. First easiest one is checking the divisibility rule for 10. What is the divisibility rule for 10? Easy, right? The last digit should be 0 and everywhere the last digit is 0. So, all these numbers are divisible by 10. And next we'll go for 3. Take sum of all those numbers and try to divide it by 3. 8 plus 1, 9, which is divisible by 3. 1 plus 7, 8, 8 plus 6. 8 plus 6 is 14 and 14 is not divisible by 3. So, option B is eliminated here itself. Okay. Yeah, Umesh Nayak is saying C, answer is C. Now, 4 plus 4, 8, 8 plus 1 is 9 and 9 is divisible by 3. So, we left with option A or option C, any one of it is correct. Now, let us check for option 4, okay, divisibility rule for 4. 4 is the last two digits will check, but here all the last two digits are 0, 0, so all of them are divisible by 4 as well. And next is, we have to check for, okay, 7 and 12. For 12, I will tell you the rule. For 12, the number should be divisible by 3 and 4. Okay. So, you always have to go for a co-prime numbers. Even 6 and 2, 6 into 2 will also give me 12. I am not going to take these numbers because these two are not co-prime numbers. And 3 and 4 are both are co-prime numbers. They both are not having any common divisor. So, you have to consider such numbers to go for the check for the divisibility rule. Clear guys? Okay. So, if the number is divisible by 3 and the number is divisible by 12, then the whole number is divisible by 12. Here, option A is also divisible by 3, option C is also divisible by 3, option A is also divisible by 4 and C also divisible by 4. So, both the numbers are divisible by 4. Next, we left with only option 7. Okay. So, we can take any of the number and try dividing it by 7. Okay. Well, we'll go for C, the bigger value, 44100, and start dividing it by 7. Okay, either you can directly start dividing it by 7, remove the last digit, subtract 4410 will remaining, again remove the last digit 0 and subtract 0, 441 is remaining. So remove the last digit which is 1 and 1 into 2 will give you 2 and subtract 2 from remaining digits, you will get 42 and 42 is divisible by 7. So answer is option C. Clear guys? Okay. So here I am explaining you the concepts behind it and that's why we are taking more time. But for you people, you should solve it within a minute, actually within 30 seconds, because these questions are easier. Okay. For that you need a lot of practice. So I hope all of you start practicing from today onwards. Okay. If you have any doubt regarding divisibility rules or regarding number system, any topic of aptitude, what you can do? There is a Telegram link in the description. Join the Telegram channel and ask any of your doubts. Okay. And we'll try to help or answer your doubts in the morning around 10 to 11. Okay. Okay. I have given you the next question and okay, options for it. Please comment your answers in the comment box. Okay, I think the answer option is already showed and now all of you will comment, right? What happened? None of you are getting answers? Or you started sleeping in the class? No, right? Please start answering, guys. And we have taken this, as I mentioned, we have taken this question from Cognizant. Okay. Now, how are we going to solve this particular question? Is a right? Okay. Now see here. Calculate the remainder if n is an integer and 2n plus 2 to the power 2 is divisible by 4. Easy. Okay. How are you going to solve this question? 2n plus 2 which is raised to the power 2 and this number should be divisible by 2. Okay. And if you divide 2n plus 2 to the square by 4, what is the remainder? You have to find the remainder, which is a question, right? Okay. Now what is the remainder? So what you can do first is, I'll take this 2 and 2 is common here. So I'll take it out of the root. What I'll get? I'll get 4 and then it is n plus 1 square divided by 4 and 4 will get cancelled, right? Now for this number to be divisible by 4, if I want to make this number divisible by 4 or else, okay, will not cancel it, 4 plus n plus 1 whole square divided by 4. Now if I substitute any value of, I can substitute any value of s, right? What I'll get? I'll get any multiples of 4 only, correct? And any multiples of 4 means obviously those numbers, the remainder will be 0. So the answer is option A. Clear guys? Okay. Now let us go for yes Umesh Nayak. Answer is option A. Right? Okay. Now I hope most of you solved these questions or attended the questions here on the test questions. Now let us go for the next topic, that is unit digit. Okay. Unit digit means the last digit of a number. For this also we have to learn a bit amount of content or the theory behind it, then we'll be able to solve the questions easily. Okay. Well, first thing is, first the unit digit and first we'll start with 0. Now what I am talking about? Let me explain you with an example. For example, if I take 0, 0 power 1, what I will get? I will get 0, correct? 0 power 2, what I am getting? I am getting 0. 0 power 3, what I am getting? I am getting 0. 0 power anything, 1, 2, 3, 4, what I will get? I will get 0 only, right? So, this 1 is what here? It is cyclicity. Now, what is this cyclicity? It is this. After the first power itself, after the first number itself, again this 0, the last digit we are talking about, okay? 0 started repeating. So, the answer or the cyclicity of 0 is 1. It is not for 0 alone, for 1 also, okay? Or for 5 also and for 6 also. How? Let me explain you. 1 power 1, the last digit is 1. 1 power 2, again it is 1. 1 power anything you raise. What? Sorry, infinity. Okay, 6 will make it. 1 power anything you raise, you will get last digit as 0. And again it started repeating after the first digit itself. That's why the cyclicity for 1 is also 1. Similarly, for 5. 5 power 1 is 5. 5 power 2 is 5. So, what happened? 25 you will get. We are talking only about the last digit, guys. Okay. So, 5 power anything you raise it, what you will get? You will get the last digit as 5 only. And that too after the first only it starts repeating. That's why cyclicity is again 1. And similarly for 6. 6 power anything you raise, 6 power infinity also the last digit is 6. Clear? And the cyclicity here is 1. Okay. So, now since we are having the for 0, 1, 5, 6, the cyclicity is 1. Always remember. Okay. Now, we will go for the next numbers, next set of numbers. Okay. Next it is 4 and the cyclicity for 4 is 2. And one more number we get in this cycle itself is 9 and the cyclicity for 9 is also 2. How it is 2? We'll verify it. For 4 first we'll check. 4 power 1 is how much? 4, right? Last digit. What is 4 power 2? The last digit is 6. 4 square is 16. So, the last digit is 6. And 4 power 3, what will get? 64 and the last digit is 4. 4 power 4, what will get? We'll get 216, the last digit is 6. So, what's happening? After 2 numbers, the 4, 6, 4, 6, it started repeating. So, the cyclicity here is 2. Six. Okay. Next is 9. Okay. Now, cyclicity for 9. Again, the cyclicity here is 2. How? 9 power 1 will give you 9. 9 power 2, if you go for 9 power 2, what you will get? 81. The last digit is 1. 9 power 3, what you will get? Start getting again the last digit as 9. Okay. So, what's happening? After the first 2 numbers only, it will start repeating. That's why the cyclicity is 2. Clear, guys? Okay. Now, let us go for the next set of numbers. Okay. So, what I am saying here? The cyclicity for 0, 1, 5, 6 is 1. The cyclicity for 4, 9 is 2. And next is cyclicity for 2. The cyclicity for 2 is 4. Because after 4 numbers, it will start repeating. Okay. So, let me explain for 1 or 2 numbers and rest all I hope you will understand. 2 power 1 will give you the last digit 2. And 2 power 2 will give you the last digit as 4. 2 power 3 will give you the last digit 8 and 2 power 4 will give you the last digit 6 because 16. 2 power 5 will give you the 32 last digit, so 2. What's happening here? After 1, 2, 3 and 4. After 4 numbers, again the cycle starts repeating from 2. So, the cyclicity is 2. Not just for 2, where you can check for 3, you can check for 7, you can also check for 8. Cyclicity for 2, 3, 7, 8. For all of it, the cyclicity is 4. Okay. So, I'll just now give you the numbers, what are those, and you sit in and try them. Okay. 3, 9, 7, 1. For 7, After that again it will start from 397. Okay. For 7 it is 7931. For 8 it is 8, 4, 2 and 6. Clear guys? Okay. So now we learned the unit digit concept and how to find the cyclicity, and you got to know the cyclicity for all these numbers. Using this, now we'll start solving the problems. Okay. Next, the first problem here is the last digit of the number obtained by multiplying the number 67, 37, 43, 91, 42, 33 and 42. And the options given are option A 0, option B 2, option C 4 and option D 6. Okay, we'll try to solve this problem. Before that, I have one thing to know here. Okay guys, now many of you are joined the classes, live class here. I don't know from which all colleges you have joined. What you can do is please comment your college name in the comment box so that I will get to know from which college you guys are from. Okay, and that would be helpful for me. Well guys, okay. Let me start with the first question now. Till here, anybody, any doubt? If you have any doubt, please comment in the comment box. Okay, no doubts? Well, now let us start with the problems. The first problem here is you have to find the last digit of this given number. How to find it? What they are asking, they are talking only about the last digit part. So, you don't need this whole number first of all. Okay. So, what you need? You just need the last digits here. 7 multiplied by 7, 3, 1, 2, 3 and 2. Okay. PS college. Okay, Mandya. Well, most of, two of them are for PS college. Now, how to solve this question? Now it looks easier, right? From this is looking easier. How to solve this? Just multiply them. 7 sevens are what you will get? You will get 49, and I don't need this whole number again. I just need the last digit. And 9 threes are 27. I don't need this whole number. Just consider 7. Then 7 into 1, 7 again. 7 twos are 14. So 4, and 4 threes are 12. So 2 twos are 4. What is the last digit? The last digit is 4. Is it simple? Yes, right? So this is how you can solve the question. Now in the same way, we will go for a bit different type of questions in the unit digit itself. So the answer is option C. I hope none of you are having any doubts. Let us go for the next question. The next question, find the unit digit of the expression 1 factorial, 2 factorial, 3 till 100 factorial. Is it looking difficult? Don't worry. The question is very simple. Okay. How are we going to do it? Let us see. What is 1 factorial? 1. What is 2 factorial? 2 into 1. 2. I hope now all of you know factorial. Okay. So 2 into 1, 2. 3 factorial, 3 twos are 6. So 6. What is 4 factorial? 24. Okay. Plus what is 5 factorial? 120. What is 6 factorial? 720. Now you can see the pattern here. What's happening? The last digit is coming as 0. After 5 factorial, you can take any factorial. The last digit is always 0. And what we need? We need only the last digit. And after 5 factorial, if I am getting all of them as 0, 0, why I have to calculate all of them? So 0 plus all these 0, 0 will together this particular number till 100 factorial is giving me 0, and add only these numbers. 24 plus 6, 30, 30 plus 2, 32, 32 plus 1, 33, 33 plus 0, 33. So what is the last digit? It is 3. Isn't it easy? Right? So the questions are difficult only till you understand those tricks. Okay guys. Well, let me go for the next question now. Answer is option A, 3. Okay. Enpoya Institute, ATME, yes. Okay guys. Praudadevaraya, yeah, ATME, Global, okay, many more colleges. Next question is, Find the unit digit of this expression, and the options are 2, 3, 7 and 9. How to approach this question now? Here 11 to the power 1, 12 to the power 2, 13 to the power 3 and 16 to the power 6. Okay, Umesh Nayak is asking once again. Okay, so well Umesh Nayak, let me complete this third question and then I'll come back to the second question and I'll explain it again to you. Okay, since we have started with this, let me finish this and then I'll explain you. Okay, question number 3. How you approach this? 11 power 1, all of them. Now to find all the last digit, you don't need all these numbers. What you need is only the last digits. Okay, that is 1 power 1. This I am simplifying. 2 power 2, 3 power 3, 4 power 4, 5 to the power 5 and till 16 to the power 6, 6 to the power 6. Okay, so 1 to the power 1 is 1, 2 square is 4, so 4, and 3 to the power 3 is how much? The last digit is 7, because 27 you will get, and then it is 7. And then 4 to the power even number. 4 to the power even number will give me 6. 5 to the power any number is 5 and 6 to the power any number is 6. Is it looking easy now? Right? Now you are understanding how those unit digit cyclicity we learned are helping us. Okay. Now add all of them and try to find the last digit. 1 plus 4, 5. 5 plus 7, 12 and 12 plus 6, 18. 18 plus 5, 23. 23 plus 6, 29. So the last digit is 9. Clear? So the answer is option D. I hope you understood. Okay. So, well, now I'll in a very short period I'll try to explain the second question again for you all. Okay, unit digit of this expression. What you have to do is, here I'll try to keep it in a brief. After 5 factorial, you take any number, the last digit will be 0. So what you have to add is, you have to add only these numbers and find the last digit. So for this, 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, 4 factorial is 24. And all this addition will give me 33. So the last digit is 33. So I hope now Umesh Nayak you understood, and anybody else who didn't get it, I hope now you guys understood the question. Okay. Let me go for the next question now. The next question here is, find the unit digit of 55 to the power 75, 93 to the power 175, 107 to the power 275. How to approach it? And the options are here. So first is 5 to the power 75 and 3 to the power 175 and 7 to the power 275. I'll give you two approaches for this question. One is this one, 5 to the power any number 5, 3 to the power 175. So what you have to do is, I'll tell you how the cyclicity helps for 3, you'll understand it now. What you have to do is, take this power 175. I told you what is the cyclicity for 3. The cyclicity for 3 is 4. Okay. Now 175 divided by 4. What you have to find is, find the remainder. If you divide 175 with 4, you will get the remainder as 3. Now you have to raise this, instead of 175, what you have to write is, you have to write this remainder here, 3 to the power 3. Easy? Now multiply 7 to the power 275. Write 7, again for 275, take 275 and divide it by 4. Why 4? The cyclicity for 7 is also 4. So 275 divided by 4, again you will get the remainder as 3. Okay. Now instead of 275, raise this 7 to the power 3. Now calculate, this gives you 5. 3 to the power 3 will give you 7, and 7 to the power 3, it will give you 3. Okay. So 7 into 3, 21, 1 into 5, 5. The last digit is 5. This is one method of solving it. One more I'll tell you, the easiest method. You don't have to do any calculation here. How to do it? Now see here guys, what is there in this expression? You have 5 in the expression. With 5, if you multiply any odd number, it will give you the last digit as 5. Check it out. If with 5, if you multiply any even number, it will give you the last digit as 0. Now with 5, you are multiplying the odd numbers here. So the answer is 5. Simply you can keep it as 5. With 5, instead of 3 and 7, if you are multiplying any even numbers, what you can do is, you can directly write the answer as 0. Clear guys? Okay. I hope you understood. And now let us start with the quiz. Okay. Harish Krishna is asking a doubt. Yes, Harish, what's your doubt? Third one, once again, please, ma'am. Okay. So, well, third one, what's your doubt here? Once again. Okay. 1 power 1. I'll try to solve it very quickly. 2 power 2, 3 power 3, 4 power 4, 5 to the power 5, 6 to the power 6. 1 to the power 1, 2 square is 4, 3 cube, last digit is 7, 4 to the power even number is 6, 5 to the power any number is 5, 6 to the power any number is 6. When you add all of this, you will get the last digit as 9. Okay. So, please add all of them and check the last digit as 9. Okay. So, yes, Harish Krishna, you are asking a doubt. Please let me know what's your doubt. Fourth question we have solved. Now, I will give you a test. You try solving some of the questions and let us start. The first question is, find the unit digit of this number. Once you get the answer, please comment it in the comment box and you have 1 minute to solve this question. Okay, Harish Krishna doubt is 5 can be multiplied by only by a single digit. Okay. Okay, Harish Krishna, it can be a single digit or a double digit. If it is an odd number, I didn't say only single digit. 5 into any odd number will give you 5. 5 into any even number will give you 0. Okay. Yes, guys, answer please for this question. Anybody? Okay, none of you got the answer. Is it looking tough? Okay. Now we'll say how much easier it is, you'll get to know now. Okay, let me solve it for you. What's given here? Oh, these unknown powers are torturing you. Okay, let me simplify it for you. What you'll get? 2 to the power m, 8 to the power n, 4 to the power x, 5 to the power y. Just now I explained you for 5, right? 5, you have even numbers here. So what you have to do? You don't have to do anything. Just write here 0 and that's your answer. Because with 5, you are multiplying the even numbers. Okay? If you still want to try, keep any of the values for m, n, x, any random values and try doing it. Okay? You will definitely get your answer as 0. Yeah, many of you got to know. Anirudh, Aishwarya, Harish, Suchet. Okay, all of you are answering as 0. Great guys, you got the answer. But try to solve it within a minute because a minute itself is a more for it. You should get it in seconds. Okay, because this is the easiest question. Well, let me go for the next question now. What is the unit digit of the sum of first 111 numbers? And the options are given here. And your time starts now. Any doubts still here? Yes, Nagprasad. Answer was 0. Oh, for this is also answer is 0? Okay. Answer please for this. 5. Harish Krishna. Very good. Others? Try to answer it. It's easy actually. Answer. Chandana is saying C. Yes, Nagaprasad, 5. Okay, let me solve it for you. Okay, it's simple. What is the unit digit of the sum? First 111 number. You might be saying, right, ma'am, you are saying all the questions are simple. But in reality, all the questions are simple. Only thing is you need to know the tricks as it. Okay. So, unit digit of sum of first 111 numbers. Now, first 111 whole numbers they are talking. Which are those? 0, 1, 2, 3. Correct? So, first 111 means starting from 0, you have to go till 110. So, these are 110 plus 0, total numbers will be 111. Okay. Now, they are asking you have to add all these numbers, and then after adding all these numbers, you will get one sum, and they are asking the last digit of that sum. If you start adding all these, it looks difficult, but you learned AP in your school time, right? Use it. Okay. Now, before that, 0 plus 1 will give you 1. 0 plus 2 will give you 2. So, with 0, you add any number, you will get that number itself as your answer. So, what you do is, leave this 0 and take a formula which you have used for AP to find the sum of first n natural numbers. What is that first n natural numbers? How will you find the sum of first n natural numbers? N into n plus 1 divided by 2. Now, what is the value of n here? 110. Okay. 110 multiplied by 110 plus 1. 111 divided by 2. 2 ones are 2, 55s are. Last digit. 5 into 1. So, what is the answer? 5. Easy, right? Okay. So, well, most of you are getting the answer. That's great, guys. Well, okay. The last question for the day. This is a bit different, but trust me, it's a very easy question. Quick, sir. Quick, guys. Yes, answers please. Why this time any of you are not getting the answer? Okay, guys. So 1 minute over. Well, it's okay. Let me help you with this question. Okay, your Shri said answer is C. That is 9. We'll see it. Okay. The rightmost non-zero digit of the number 30 to the power 2928. Okay. Suppose for this 2928 is a question. If you take this will become, if you want to find unit digit, then it will become 2928, 0 power anything is 0. So, the answer for this, the last digit is 0. But we don't want that. What they said, the rightmost non-zero digit means the digit which is next to this or which is in the 10th place. Now, how you find it? We'll do it. 30 to the power 2928. So, this 30 to the power 2928 will split it. How? 3 to the power 2928 multiplied by 3 into 10. 10 to the power 2928. This we already know. Last digit is 0 and we got it. Now try to find the last digit for this. And that's your answer. Now you already know what is the cyclicity for 3. 2928 divided by 4 because the cyclicity is 4. Now you don't have to divide all these numbers. You also know the divisibility rule for 4. Right? You just need to try dividing this last 2 digits. So that means 28 divided by 4. Is 28 divisible by 4? Yes. So the remainder is 0. And 3 to the power 0. Okay. Then this will become 3 to the power 0. Suppose, please remember this guys, it's very important. Whenever you get any number to the power 0, 3 to the power 0, 2 to the power 0, 7 to the power 0, 8 to the power 0, any number, if you get power as 0, that is remainder as 0, then replace it by 3 to the power 4. This applies only for the numbers which are having the cyclicity as 4. Okay, this I am talking only for the numbers which are having cyclicity as 4. I am repeating. So 3 to the power 4, you have to replace it by 4. So for 3 to the power 4, the last digit is 1. That's why your answer is 1. Yeah, someone Hari Krishna has mentioned answer as already 1. Yes, Hari Krishna, answer 1 is correct. Okay. So 4. Okay. Now why it is 3 to the power 0 is 1. If you have any doubt, please do a research today, and if you still don't get it, ask me a doubt tomorrow, we'll clarify it. Okay guys, till here I hope none of you have had any doubt. If you have any doubts, I'll give you 5 minutes and please clarify all your queries. Well guys, if you don't have any queries, and then we'll end this session. Yes, anybody, any doubts? Please reply, any doubt, no doubts, something. Do you have any doubt or you don't have any doubt? Okay, which one to repeat? Yes, Nag Prasad, which one to repeat? Last question. Okay. Well, it's not recorded. I have to do it again. If you want, you can do it. So I'll just simplify it and give you 30 to the power 292a. What you can do is, you can split it into 3 to the power 292a and 10 to the power 2928. Okay. When you multiply it again, you'll get the last digit here 0, and you have to find only for this 3 to the power 2928. Okay. When you start doing it, you already know the cyclicity for 3 is 4, and you also know the divisibility rule for 4, right? The divisibility rule for 4 is the last 2 digits only you will check. If the last 2 digits are divisible, then the number is divisible. Okay. If not, you will get a remainder. Now try dividing 28 by 4, but 28 is completely divisible by 4. That's why the remainder is 0. So what you will do is, you will raise this power to 0. For any number which is having the cyclicity as 4, which are the numbers which are having cyclicity as 4? 2, 3, 7, 8. These 4 numbers having the cyclicity 4. For these numbers, if you get the power 0, 3 to the power 0, 7 to the power 0, 8 to the power 0, please replace it by power 4. 7 to the power 4, sorry, 8 to the power 4. Okay. So 3 to the power 4 here in this case, which is 3971. So it is 1. Okay. Well guys, anyone else? I hope you understood it now. If you still have any doubts, you can go to. Okay guys. So no queries. Well guys, let me tell you what we are gonna take in the next class. In the next class, I'll be starting with, we'll learn some of the tricks about reminders, and we'll learn the problems on reminders, and then we'll take HCF and LCM. Okay. So I know most of you know HCF and LCM, but the thing is, most of you don't know the application of HCF and LCM. Okay. And the questions on it. Again, the questions will be from model question papers. Clear? Okay. So I assume that the class is helpful for you. If you need any changes in the class, please do comment, and I'll try to implement all those changes. And if there were any technical issues, if you have faced any of them, you can do mention that also. Okay. Well, let us end the session. Thank you so much, guys. Have a nice day. Actually, have a nice evening. Yes, thank you, Chetan. Thank you, Nagaprasad. Thank you, Suchet. Filmy Rocks. I don't know who is Filmy Rocks. Hari, Suchet, everybody. Thank you, guys.